So, as we mentioned last time, till last time we were working on a fully drawn yarn, and we had looked at the machine parameters and process parameters that were governing them. So, the material process parameters that were likely to influence texturing and their effect on textured yarn we have done, but this was a fully drawn yarn. And also we looked at any other parameter that could influence. So, these constraints still remain. Thermoplastic yarn we are talking about. We are looking at multifilament yarn, but as we move on, we will try to remove this constraint and look at something which is not fully drawn yarn as well. All right. So, this we will discuss what is the need and the concept of draw texturing, the challenges in terms of materials and machine in coming lectures we will work out, and in this respect we will discuss in the next few lectures the emergence of a POY and friction texturing, but today we will not be doing any friction texturing, but this is what is. So, constraints have changed. So, we now have another material which will be called undrawn yarn, or which is not a fully drawn yarn. So, therefore, because it is not a fully drawn yarn, therefore, we have to do drawing, all right, and therefore, this texturing process will be called draw texturing. One of the interesting thing one can always remember in this industry, which is the false twist texturing, there has been a good close cooperation with the R&D development institutes, fiber manufacturers, machinery manufacturers, all of them contributed their might for the success of this technology. So, this was not like you have some problems in one and you keep blaming the other person that your machine is not good, your material is not good. They understood that now they are dealing with a different material and everything has to be differently done, and therefore, a big cooperation has been there. So, everyone has been helping each other to understand the problems and also then find solutions to the problems. So, what was the problem? So, you were doing good amount of texturing, material was understood, the process was understood. So, what was the problem? One of the problem was called Bari. Now, one interesting thing is Bari is a problem which gets generated after dyeing. Dyeing is done after you have done texturing. So, it is very easy to blame the dyer. You are not doing your job good and therefore, there is a problem. So, we have nothing to do with it, all right. We have given you a textured yarn and a fabric made from textured yarn. If your dyeing is causing a problem, then you better look after your dyeing, all right. So, Bari is considered as a regular irregularity, that is, you can see bars, lines which are more appear to be deeper dyed than the rest, and so you can identify them on the fabric. If it is used as a fashion statement, there is no problem, but most of the people would like to have a uniformly dyed material, uniformly dyed fabric or a garment, and therefore, these things are not appreciated. So, this was one of the problems which people face from the textured yarn. So, texturing was good, everybody wanted a textured yarn, they understood the importance of stretch and bulk, optimize all properties, and then you suddenly find, well, there is something else which we are not able to look at. So, regular irregularity in fabrics. So, this appears when you make a fabric, knitted, woven, whatever. And why does this come? And why textured yarns? Because every time you set up any kind of a process parameter, there are going to be range in under which you work. A temperature is not a fixed point, you have a plus or minus accuracy, right. So, you fix up 210, but it will be temperature at any given point of time will be 210 plus minus something. So, similarly, any kind of a measurement that you do would have its own variation. Then this material that we are using is a material which has been drawn before. So, if someone has made some difference in the drawing conditions, that also will get added up. So, you have a material which you always thought is a fully drawn yarn, it has got the same property, it has got the same denier, it has got the same number of filaments, looks same, but the morphology may not be same. A fully drawn yarn is not a product which has only one, or we have only very specific properties with specific values, but they have range. And because they have a range, and then you are again doing texturing. So, there is a thermal history, there could be a stress induced crystallinity which happens during drawing, that could be history. Then you have certain materials like polyester are drawn also a little higher temperature, and so they have a history. So, in a large machine which has got large number of spinning units or texturing units, all of them spinning and texturing yarns, which according to the whole calculation, the machine is supposed to be running the same speed, all the temperature at all the heaters is exactly same. All this is a big assumption. And if you remember that one curve, at least with temperature, you remember, of a dye uptake, it follows some curve like this. That means the optimization part had to be seen, that whether you really wanted to do the optimization in terms of crimp rigidity, crimp stability and tenacity, and then not worry about it, that is one. But what it shows is that if there is a change in morphology, the dyes which depend on a solid solution theory, that is, they believe in some kind of a space there in the fiber which is going to be filled or occupied by a dye molecule, then any variation there is going to lead to a variation, and that is a dyeing variation. That means after dyeing you will see. They say, well, this kind of variation will always be there, what can you do? So, Bari people defined as two types of problems in the Bari. One, they called it a rogue. A rogue, you understand, is something which does not follow any law. So, we will do something which is very different from the others, not necessarily in the positive way. So, a rogue Bari would be considered to have happened if the depth of shade or the dye uptake or dye on a fiber or a one yarn is 2 to 5 times higher than the next one, 2 to 5 times higher. This is theoretically easily identifiable, it does not require one single yarn will be seen if it is there. The only thing is that there is always a process before you actually send anything for weaving and knitting, that some textured yarn knits would be tested for dyeing also, and then you send them. And if you find there is a rogue kind of a thing, and maybe one of the heater was not functioning very nicely, and therefore, something like that happens. That is so different, easily identifiable. So, if it is easily identifiable, you will remove it and not give it to someone, because if you give it to someone, then definitely there are rejects, nothing you can do about it. The other is called a block Bari. Block means if the block of yarns with a different dye uptake come together, then they are visible. If they are individually lying anywhere, then it is very difficult from the naked eye to find a difference in a dye uptake. The difference will be 2 to 5%. You see, here you were talking about 2 to 5 times. Here we are talking about difference of 2% to 5% difference in the dye. So, 2% difference, it is not 2% shade, it is a 2% difference in the shade. So, with the naked eye you will not be able to find. In fact, it is very difficult, even two yarns are lying together, one of them is 2% higher and the other is 2% lower, you will not be able to distinguish whether they are actually differently dyed or not. But if they appear in block, the 10 of them or 5 of them come together, which have higher, then you will be able to see if there is a bar which is running. So, both are bad. First one is so bad that you have to throw, right. So, that people say, well, somebody slept when the machine was not functioning well and did not do the job. But the second one can happen anytime. That a little variation in temperatures of texturing, little variation in temperature of the previous process called the drawing could cause this difference. So, say how would you do that? What will you do then? Then this will always happen, you know. The rogue, you can say, well, we have had a problem, we will take this yarn absolutely out of our line and then not supply it to anyone. Block you cannot avoid very easily, because something will always happen. And one of the reasons which people found is that the error that you cause or create during the drawing itself get only accentuated. This term, you understand this term COP? Right. So, this package normally from the drawing section or the draw twisters, when it comes, is in the range of 500 grams, 750 grams, so on and so forth. So, that means the textured yarn will also have the same amount of yarn, because in the filament yarn you must understand nobody puts a knot. If the filament breaks, then you close the package, right. So, there is no way of splicing, there is no knotting. So, you just stop. So, that means there are large number of such COPs on the machine which are being texturized, which may have a different history and which may have been very difficult for you to find out what is the change, morphological change within the thing. Otherwise, you test each and every package, go through the X-ray machine, go through all kinds of stuff and then say, well, I think this is A class, this is A1, this is A2, this is A3, tough, and still you can cause problems at the end also. One of the things which they found is, if you can disturb the block, that is on a knitting machine, if there are 36 packages lying, then you change their order, the block gets disturbed and the block Bari can get disturbed. That is, somebody who is knitting can always juxtaposition the packages and suddenly you will find, well, the block is gone and you may not see it. That is one. But then again, first you make, then you find, then you change, then you find. So, even if you got a package, you may be able to do that. But what was interesting to note was that the doffs of the undrawn yarns were obviously of higher weight, 5 kilogram, 7 kilogram, big doffs coming from a spinning machine. The spinning machine runs 24/7. The draw texturing unit is whenever you get a thing, you draw it, you can stop, you can do, so those kind of things. So, the idea was that can you actually get a singular history at least at some place and not change them often enough. So, that is why I say, well, then we will have to work with the spinning DOF rather than which goes to the drawing unit, then you take a drawn yarn and then texturize. Some of this was being done within the industry itself. So, therefore, they said, can we do something like this, draw texturing. That means drawing to be done on the texturing machine. So, instead of getting a fully drawn yarn from somewhere, you say I will get an undrawn yarn and we will do the drawing here. So, I have, let us say, more control probably, and I will know the history if something has happened, and accordingly we will package them and sell and market, whatever. So, idea was that if there is a large package, the change will be less because the history of the large package will continue for a long time, and so all the texturized packages, which will obviously not be 5 kilograms, they may be 500 grams kind of packages, they will be having a same history. You can then segregate them and work around and hopefully would help. So, that is how the draw texturing came into picture. But remember how? Not because crimplicity was bad, not because yarns were fused, not because there were breakages happening in texturing, but dying. The problem identified somewhere else, pushed back to the texturing people and industry, and they said, okay, it appears a serious business, let us do it. That is what the cooperation part of it. So, it is a new process which was obviously different than what people had done before. So, you can take an undrawn yarn, go through a process called sequential drawing. That means you take an undrawn yarn, have a drawing unit on the machine, and after it has been fully drawn, then you texturize it, and then that will be called a draw textured yarn. So, on the machine you will have drawing unit and your sequence is first draw, then texturize. So, called a sequential draw texturing. The other possibility was that you do the drawing and texturing simultaneously, no drawing unit, no separate drawing unit. The drawing is being done during texturing, and then you get a draw textured yarn. So, two different routes could be done, which would happen, both the processes would happen in the texturing industry or on a texturing machine, or the people who are supposed to be called throsters. They are the ones who said they will do this machine if there is a modification done. So, you have this feed roller, and then this goes, you have the heater, the twister, and the take up roll. So, this is the way we were operating our false switch texturing. So, what they said is let's put another set of roll before this, and between these two rolls you do drawing. If this is what you do, so this is a sequential process. First draw and then texturize, but on the same machine. This was not difficult to do, because only thing you had to do was another set of roller which will be running at a speed lower than this number 2 set, while the number 3 set would be exactly same the way whatever you were doing. So, I said this is easy to do as long as we believe that we can handle the DOFs, and then this particular thing could be done. So, what kind of a challenges were there? From the point of view of the property of the textured yarn and optimization, there were very less challenges, because you were anyway handling at that time the fully drawn yarn. And at the point number 2, as it exits, it is a fully drawn yarn. Okay. If it was a nylon, it goes like this, or if it was a polyester, one could put a hot pin over which the yarn is moving. So, the temperature of the yarn could be raised, and then you can do the drawing. So, this was all done, simple extension, or a machine could actually get to the sequential draw texturing. So, from that point of view, people were happy, except that you need some space where this particular part also has to be fitted, yarn coming from creel and between this and satisfied. Somebody has to be taught. This is also an important thing which requires a different temperature, different draw ratios based on the characteristic of a undrawn yarn. How many people have seen stress strain curve of an undrawn yarn? You have seen? How would it be there? Same as textured yarn. So, something similar, but one sees something like that. That is, initially there is a stress build up, then something like a yield point comes, and then there is a flow, and then you get the normal yarn, which is like a fully drawn yarn if everything is done correctly. The difference between textured and this yarn is, this is not going to go back, all right. So, when you release the strain or stress, it is not going to go back, it is a transformation, all right. During this transformation, obviously what were happening was stress induced crystallization or thermal plus stress induced crystallization was also taking place during. And so, there is no question of the yarn retracting back to the original position. In the stretch yarn, what we saw is, no, it goes back, and that is what we want, but in this case this does not happen. But at the end of this point, you have a fully drawn yarn. Whatever was being obtained from a draw twisters, something similar you will see from here also, right. So, the only change is that there has to be some additional drawing unit which should be attached, and which machinery manufacturer said no problem, we will easily do that, and let us see what happens. So, the question is, you started with this problem and you say, well, this can be done. So, could you address this problem? So, I said yes, we could address this problem, that having a similar history or a prehistory of a material always led to a better material. So, we are not looking at the rogue Bari, which means machine has stopped, heater may have not worked, somebody is just sleeping. That problem is not the one which is looking at to solve, but the problem of the block, variation within the thing getting reduced, and so it is suddenly fine, well, you can work around, and the Bari was addressed. So, you should be satisfied, keep doing sequential draw texturing. But there were some issues which were also raised. One of the issue, this was addressed, let us say yes. The other issue which was raised was that the so called undrawn yarn was being spun at 500 to 700 meters per minute speed, all right. This is how the spinning was being done, nylon, polyester, things like that. Then the drawing was being done by somebody else. So, drawing was being done at around 700 to 1000 meters per minute. So, that is one, but no problem, because these are two processes which are discontinuous process. Spinning is happening somewhere else, drawing is happening somewhere else. It is just something which you understand, okay, that there is a large DOF being created, DOF will go to the drawing unit machine, the drawing machine will do the drawing, get the cops, and the cops will be supplied to texturizing. The texturing machines were running at 200 to 250 meters or even less. So, essentially what they said is that by adopting this method of sequential draw texturing, you have reduced the speed of the whole process. The drawing has become slower. Something which was happening, a production was good high, now everything is all right. If you are very happy with the Bari, is fine, but at least you must appreciate that you have slowed down all processes, not the spinning of course, because spinning is disjoint, but what you have joined is drawing and texturing. So, there is a mismatch in the speeds, therefore, you are reducing the speed. If it is okay with you, then it is fine. Then the question is, okay, look, if we are doing whatever we are doing, then can we not, when this disadvantage is there, because our texturing machine have certain speeds and we have to live with it. And that time, if you remember, we had talked about something called pin texturing. Remember pin texturing? The twister was a pin, all right? The spindle was a pin. And at what speeds you are rotating? 10⁵ RPM, right? Running at that kind of a speed, you could get this speed. And so, the big challenge was there, of course. But main thing is, because you were texturing at a slow speed, the drawing was getting slowed, then people said, well, if that is to happen, let us try not to have a additional drawing unit to the spinning texturing machine. Why don't we do the drawing while we are texturing? Because the feed roller speed and the take up roller speed could then be adjusted anyway. So, why can't we do that? So, based on that, they said, well, we are happy with the sequential, but let us try this where no additional drawing unit will be required. We just change the speeds of the two sets of rolls. So, that made common sense. If you are not getting the advantage of speed, at least get the advantage of space, and let us see what happens, right. So, they say, let us do simultaneous draw texturing. This was a process which was totally new. No one in the texturizing industry had any idea as to what is going to happen. In the sequential case, it was very clear that you were texturizing a fully drawn yarn, and though optimization was already done, now you had a material which was different material, absolutely different material, and now absolutely different process. So, there was a big challenge on this, and which obviously, as I said, the people in the texturing industry, the people in the R&D and the research institutes obviously looked into this problem as well. And the problems were created initially by the material itself, which was called the UDY. So, material itself was a problem, creating problem. Machine problem obviously would be there, but that has to be handled differently. but let us first see what is the material problem that you are talking about. UDY, you understand, approximate speeds at which it is being done is 700 or 500 to 700 meters per minute. The undrawn yarn had three major problems. One of the problem was called aging, that means storage stability. Earlier what was being done is that you had the DOF was being drawn, the drawing machine was obviously in the premises of the fiber manufacturer itself. So, the DOF will go to the drawing section, drawing will be done, copse will be collected and then supplied to textured yarn manufacturers wherever they are, and they were quite happy with that. So, what they found was after a week of spinning the material, if you have not used it, there is a property deterioration based on the temperature of storage and the humidity. You can control, of course. So, the problem was that you must use this material within 7 days. Easier said than done, because after the DOFs are removed, you have a quality check. After that, somebody decides how to pack, somebody is segregating and then packing them. After packing, they are excise duty and whatnot, then you are taking it somewhere else for texturizing, transportation time. So, you would lose not less than 3 to 4 days in just deciding and transporting, maybe more, when you find there is a problem of aging. That means they did experiments and found, well, yes, there is a degradation taking place of the material. So, obviously, if instead of trying to solve a problem, you are not creating a problem, because this history is going to be much worse than the history of a drawn yarn, because and once you cross that limit, then every day you are actually making a different product, and so this was a bigger problem. So, the die uptake would increase, they found that die uptake of the yarn would keep increasing as the time progresses, which meant exactly same thing which would happen in the Bari. And then the customer, the texturer will say, I am not going to use this yarn at all, there is no point, I am not using it. So, then the spinning units, the industries thought that they can put a texturizing machine within the complex and they start doing texturizing. Now, so they want to become experts in texturizing, there is a difficult thing again. Now, this is a case which was also not considered very nice. Threading. So, what was the threading? So, this was the pin which was being rotated in whichever way, and the yarn was supposed to be going from one direction into a hollow arm and the tube and get out from the other side. Every turn means one twist, so that is okay. So, this is not the problem that threading was a tough one, you thread once and then start the machine, everything is okay. But the problem was, you start the machine and the moment you start, the undrawn yarn touches the heater, it will just break. So, that is one. So, if you do something and start, and there is a break for whatever reason, then you again restart. So, they found with so many breaks, and I told you, in a multi-filament industry, break is something nobody likes. Nobody likes breaks anywhere, but in the spun yarn you have knotting allowed, splicing allowed, they can keep making the yarn continuous. Here, it's broken. So, you may have a 100-gram package, so its 100 gram is finished. So, it becoming. So, the material will fuse onto the heater. So, this was so weak a material. So, they said we will do one thing, will, before starting the machine, we will pull the yarn with our own hands and then start the machine. After that, anyway drawing will take place, right. But cumbersome, how much drawing has been done by the man, maybe you can waste that yarn, but that was it. So, every time threading was a problem, the people who were working really got fed up because this is not the material we want to use. So, you are giving a material which we do not want to use, and so this was one problem. So, okay. Then they found another thing, that the tenacity of sequentially textured yarn was higher than that of the simultaneously draw textured yarn. So, in this case the tenacity was low. We did say that, well, tenacity is not an important thing, but you suddenly find that almost every material that you produce is poor, then you have to worry about it. So, if you have so many problems coming in a sequential draw texturing, then you say this is not the process that you want to adopt. So, one of the ways was that leave it, forget it, go back to the sequential draw machine, a draw texturing machine, and work it out. It will keep working. So, that kept on happening, but simultaneously people wanted to know, let us find out the cause, all right. So, because it is a less crystalline material, let us say polyester is hardly any crystalline material when you just spin. The crystalline develops during the drawing and then heat setting and so on and so forth. So, without any material like a non-crystalline material, it is a very unstable system. You just pull something, it changes, and the void, shall I say, or the moisture absorption capacity of this material was also high. So, everywhere the moisture is there, temperature is there. In a polymeric system, you have a moisture and temperature, well, peroxy radicals will form. If light also is there, oxidative degradation happens. So, we say, well, you will getting degradation. That is a known thing because you have not drawn. Otherwise, normal draw ratio would be 3.5, 3.8 draw ratio, and now it has not been drawn or very less been drawn just because some speed is there. So, that was problem, and because of this also stability was very low, and then it could just fuse, the movement touches. So, you had to absolutely avoid that, the heater before the machine will run, and then tenacity is poor. So, nothing was actually appeared to be nice for the sequential draw texturing machine. Why was the tenacity poor? They wanted to know. Even if you can handle something else, I can put the texturing machine in the same unit, but still tenacity is not good. So, they found there is something called migration. And how did they find? They did a stress strain analysis of the same textured yarn. Just trying to remind that the normal textured yarn, when you actually want to study the property which is the tenacity, etc., you decrimp first and then test. Otherwise, the jaws are just moving. You understand? You are an undrawn. So, you do a pre-tension and then test, right, the tenacity. So, in the case of sequential draw texturing, the curve was, let us say, like this, approximately textured yarn. So, it would take the stress and after some time just break. That means, there are 36 filaments or more, they break approximately same time. This is called a catastrophic break. So, you keep stressing and then catastrophic failure, that is one. When they did test the one on the simultaneous textured yarn, they got a curve like this. Now, this curve, as I said, the stress strain curve is simple experiment, can also give you information. So, what this information says is staggered break. That means some filaments are breaking first, then the others are breaking, then the others are breaking, then the others are breaking, then the others are breaking. But what you have done, that every filament has a different kind of property. Now, why? We thought that twisting was a good idea, so that every filament on an average length along the length of the yarn would get the same treatment, that the fellow would be sometime on the surface, sometime in the core, sometime in the middle, all the filaments the same opportunity. That was called migration. So, filaments are migrating from surface to core and coming, all of filaments were at the same chance. Now, when you used this simultaneous draw texturing, what you were doing? You were also drawing together while you were twisting. So, they found probably the migration was not happening as good. The material which were on the surface probably had less chance to go inside. Why? Because the stress that they were actually experiencing because of being on the surface, because of that they would permanently extend. So, tension was less reduced. This migration was happening because of the tension differences on the surface yarn versus the yarns or filaments in the core. Now, if it is drawn, then there is no tension left. So, there is no reason why somebody will give us, space for it surface yarn to go inside. So, you could lead to a poor migration. So, you have core, some of them may be lying there, the others may be lying here, and they are not switching positions. If they do not switch positions, then they have a different history. So, the one which are on the surface probably have already been extended compared to the ones which are in the core. And then at top of it, you are also doing some drawing. You have done a normal draw ratio, you have given a normal draw. It required, let us say, 3.5 draws, or you have given 3.5 draw. So, what happens? If this is the normal draw value, then some of them will be overdrawn, some will be underdrawn, all right. So, one which are underdrawn obviously are, finally when you extend them, they may draw later or break at a higher extension value. So, whenever there is a situation when all the filaments are not taking the load or sharing the load properly, then the overall registered tenacity becomes low, other than the problem that you see. So, you found one reason, migration, and the other reason was necking. When you draw a filament parallel to its axis, you draw stretch parallel to its axis. So, you have a larger diameter undrawn material, as it is being drawn between two sets of rollers. Let us say one set of roller is here, other set of roller is here, and you are drawing. Then suddenly you see the diameter changes at one point. It is not continuously, does not change, and so this becomes a constriction which helps the fibers to get oriented, as if everything on this side is amorphous mass, and then you are pulling through a constriction, and so they get pulled and the orientation becomes better. Right? This is how the normal drawing takes place, right. So, there is a necking. So, necking is very important. It is not a gradual change of a diameter. You can see it if you go to an industry or any other drawing machine. If you keep looking at it, you will find there is a necking happening at one point, and generally it will be approximately the same point. If the material here is the same, the speeds are the same, vibrations are controlled, then you say necking is almost happening at the same point, and which is important for orientation part of it. And orientation has something to do with tenacity, right. But in our case, the yarn which is actually getting drawn is not parallel, they are twisted. Now, you have a twisted yarn which you want to draw, you can appreciate what is going to happen. We anyway said texturing is a disorientating process. On top of it, now while during drying itself, you are creating another problem, right, because of migration and because of the drawing. What they found was that in a twisted kind of configuration, this necking zone was not sharp, it was extended necking zone. So, pulling was not as nice as you would have probably loved, and the yarn also being presented at the point probably like this, like this, like this, maybe like this and like this. So, still not in parallel. So, all of them are leading to a material which is going to give you poor strength, poor migration, and not the best way to draw. So, a problem that you started to solve called Bari, you are now landing up into another problem which is more severe for every time. So, you can appreciate hardly anybody who is working on a texturing machine would say I will work with it, right. So, this was the problem. So, we stop here, and next time we go further from here. Thank you.